All right, so in part 2, you learned about naming ions individually. Now in part 3, we're ready to look at naming ionic compounds. That is, substances where a metal and a nonmetal are joined together in an ionic bond. Let's get started. We're going to start with the easiest type, which are called binary ionic compounds. The word binary refers to the number 2. So binary ionic compounds are made up of just 2 elements combined together. One is a metal, one is a nonmetal. When we deal with ionic compounds, we know that they are neutral. What that means is overall it doesn't have a positive or negative charge. What it means for us is that when we write a formula, we have to have the positive and negative charges balanced out. To accomplish this, we can use the crisscross method. This is kind of an easy way of figuring out the formula to make it neutral. To use the crisscross method, you start out by writing the ions, so you would start with their symbol, and then fill in their charges. Once you have their charges written, then you crisscross the numbers, ignoring the signs. Let's look at an example, and I think this will make more sense. In the first one, we're going to name or write the formula for iron 3 oxide. Notice that there's 2 parts to this name. There's the iron, there's the oxide, and there's this Roman numeral 3. What was this Roman numeral 3 telling us? Does it belong to the metal or does it belong to the nonmetal? The Roman numeral is telling us the charge of the metal. So in this case, a Roman numeral of 3 means that our iron had a positive 3 charge. Let's write the symbols. Iron symbol is Fe, capital F, lowercase e, and I'm going to fill in its charge as a +3, given from the Roman numeral. Oxide over here has the IDE ending because it was a nonmetal. And then I need to know what element was OX representing. Of course, this is oxygen, so I put the symbol for oxygen, O, and then I need to put its charge up there. The charge for oxygen would be a -2 because it gains 2 electrons. Now I'm ready to crisscross. When we crisscross, we circle the numbers, ignoring the charges, so leave the positive and negative alone. We know we always have a positive and a negative ion. Now I'm going to crisscross the numbers, bringing them down to be subscripts. What I get as an answer here is Fe with a little 2 after it. So the 2 that was the charge of the oxygen becomes the subscript on the iron. The oxygen, on the other hand, gets the 3 that was the charge of the iron as its subscript. So our final formula is Fe2O3. Let's actually skip down and do potassium nitride next. In the name potassium nitride, we have 2 parts. We have potassium. Potassium is an element whose symbol doesn't look anything like its name. The symbol for potassium is K. It's in the first group, so its charge is a +1. Then I have this nitride. Notice again the IDE ending means that it's a nonmetal ion. So I need to know which nonmetal starts with NiTr. Of course, this is nitrogen. Nitrogen has a -3 charge in order to become stable. What I do now is crisscross. When we crisscross, we take the numbers, circled, and bring those down to be the subscripts. The formula that I would get now is K with a 3 after it. That came from the charge of the nitrogen, and N with a 1 after it. That came from the charge of the potassium. Now hopefully you've learned by now that when you have a subscript of a 1 in a formula, you don't have to show it. So I can write this as just K3N. The 1 is understood. It's kind of like in algebra class. If you just write X, everybody knows you mean 1X. When we don't show a number here, everybody knows we're talking about a 1. I'm going to start a good practice of boxing my final answer. So I'm going to box this to show it was my final answer, and I'll go back and box my final answer from the iron 3 oxide. Now let's do the one we skipped. I skipped it because it has a little bit of a trick to it. Let's start by writing our 2 ions. We have calcium, whose symbol is Ca. Calcium has a +2 charge. Sulfide has the IDE ending because it came from a nonmetal. The nonmetal started SULF. Well, that would be sulfur. Sulfur has a -2 charge. Now when we look at that, you might notice that a +2 charge and a -2 charge would cancel each other out right away. If I try the crisscross, look at what formula I get. The formula I would get out of the crisscross is Ca2S2. If you think about this mathematically, a ratio of 2 to 2 is the same as a ratio of 1 to 1. I would actually reduce this answer to write the formula as just CAS. So when you have the same subscripts on every element, you can reduce it to the lowest possible term. So 2 to 2 would reduce to 1 to 1. I could also tell this by looking at the charges in the first place. Because I had a positive 2 and a negative 2, those two would cancel out with just one of each element. So in these examples, you were given the name and we wrote the formulas. Let's try going the other direction now. On the next slide here, we see the rules about writing the name for your compound. In order to write the name of an ionic compound, we're always going to start with the name of the cation at the beginning. The cation goes first. Remember, if we have a type 2 metal, these are metals who can have multiple charges, then we have to use Roman numerals to show which charge it has. The Roman numerals are listed for you here, so you can review them. This is 1, 2, 3, 4, 5, and 6. Once you've written the name of the cation, then you're ready to write the name of the anion. The anion, remember, is the negatively charged ion. It will always be written second. So the metal always comes first and then the nonmetal. Remember that when we named anions, they had to get this IDE ending. So we will continue to do that here. Are you ready to try some examples? For this problem, we're asked to write the name of the following compounds. So notice here we're given formulas and we write names. I'm going to start with COI3. CO is the symbol not for copper. Copper is Cu. CO is cobalt. So I'll start by writing the name cobalt. Remember, metals don't change their ending, so it just stays cobalt. What I always ask myself at this point is, does the metal need a Roman numeral? When I look on the periodic table, I see that cobalt is considered a type 2 metal. It's a transition metal, which means it can have a variety of charges. Because it can have different charges, it needs a Roman numeral so that we can tell what its charge is. I'm going to put the parentheses there to make a spot for the Roman numeral, and then I'll come back to it later. Let's name the second half of the molecule now. The anion part was the element iodine, but because this is an ion, remember we have to change the ending. So instead of iodine, it would become iodide. Now let's fill in that Roman numeral. I like to think of this in one of several ways. The easiest way I can think of to explain it is called undoing the crisscross. Do you see this 3 right here? Where did that 3 come from? Well, it came from the charge of the cobalt. That tells me that my cobalt had a +3 charge. When I look on the cobalt, there was no number as a subscript, which would be implied to be a 1, which meant that my iodine was a -1. Because I'm interested in the metal here, I'm going to take this +3 charge and write that as the Roman numeral. That's telling me the charge of the cobalt. Another way to think of this is algebraically. Notice how I had 1 cobalt in this formula. So I had 1 +3 ion. On the iodine side, I had 3 -1 ions. So 1 +3 ion would cancel out 3 -1 ions. So cobalt 2 iodide is the full name for this formula. In the next example, we have Cu2Se. Cu is the symbol for copper. So I'll start by writing copper. The metal's ending doesn't change. Does copper need a Roman numeral? Well, copper is a transition metal, and it's not one of the 4 special ones that I memorized. For that reason, copper does indeed need a Roman numeral for me to tell what its charge is. Again, I'll put the parentheses there and come back to fill in the number at the end. Let's name the other half of our molecule, of our compound here. This is Se. Se is the element selenium. In this case, remember, like with all nonmetals, we have to change the ending. So I'm going to drop the IUM ending that you find on the periodic table and make it an IDE ending. Now I need to figure out the Roman numeral. Again, if I try undoing the crisscross, I see a 2 here, which meant that the selenide had a -2 charge. What number is down here on the selenium right now? Well, there's no number, which we would assume to be a 1. What that means, if I undo the crisscross, is that my copper had a +1 charge. For that reason, I fill in a Roman numeral of 1. Remember, you can also think of this algebraically. I'll write it off to the side so it's a little easier to see. 2 positive 1 ions would in turn cancel out 1 negative 2 ion. So if you add the positive terms plus the negative terms together, they give us a total of 0 because the whole compound is neutral. The last example on this slide is actually the easiest one. Let's start by writing the name for Ba. Ba is the element barium. When you look on the periodic table, notice where barium is found. Barium is found in group 2 of the periodic table. Because it's in group 2, that means it's a type 1 metal. In other words, it's a metal who always has the same charge. It's always a +2. Because it's always a +2, there is no Roman numeral needed. It can never have any other charge, so I don't have to put parentheses with the Roman numeral here. Now let me look at the O part. O is oxygen, so I would start that name, but I remember that I have to change the ending to an IDE. So the full name here is barium oxide, no Roman numeral, because the barium can only ever have a +2 charge.